Hello everyone. So today we are going to discuss about Darcy Law. Before reading the definition, let's first look at this diagram. This is a experimental model of Darcy. What he did, he just take a hollow pipe, tunnel shape pipe, and fill it filled it with sand, okay, and then locked both sides with a permeable membrane, and hang this pipe from ceiling, and both end of the pipe was hanged at different height, means at a different height from the ceiling. This one is suppose h1 height, and this end was hang to the h2 height. Now he poured some water from this pore from h1 side and collected it to h2 side and measured the velocity of the water. Now what he was trying to found that he was trying to articulate that what are the factors which affect the flow rate, means flow velocity of the water. So he found that head difference directly proportional to the flow rate, means more the head difference, means difference of h2 minus h1, the value of h2 minus h1 is more, the flow rate was increased. This is obvious things, because of gravity. If you take a slope of this pipe, if you increase the slope of this pipe, if you hanged it at a steeper slope, then obviously flow rate would be increased. And if you hanged it at a gentler slope, if h2 and h1 difference is very low, then flow rate would be less. So if he found that flow rate is directly proportional to the head difference, and he at the same time found that flow rate is inversely proportional to length, means if he took the long pipe, then he found that flow rate get decreases, and if he took the shorter length pipe, then he found that flow rate get increases. So what he concluded, that the flow rate is directly proportional to the head difference and inversely proportional to the length of the pipe. So a definition of the Darcy Law is based on this conclusion, that the flow rate through porous media is proportional to the head loss and inversely proportional to the length of the flow path, is known as a Darcy Law. Means simple, this conclusion become the definition of the Darcy Law, that flow rate through the media is directly proportional to the head difference and inversely proportional to the length. And this came into formula also. This is a formula of Darcy Law. Q is equal to minus Ka dH by dl. Here Q is the flow rate, which unit is meter cube per second. K is the hydraulic conductivity. This is based on the material, quality of material, and various other factors. A is the cross section area. dH and dl. dH is the head difference, h2 minus h1, and l is the length. Okay. V, here look at another formula. Here V is the Darcy velocity. We known as a V as a Darcy velocity. We did here, what is V? Q by A. So what we did, we just interchange the side. Okay. Take the A in left side. So here it is a multiplication, so it would come here as a division. So the same formula, we just interchange the side, and this formula become Q by A is equal to minus K dH by dl. Okay. So Q by A is the basically Darcy velocity. Q by A is known as a Darcy velocity. We represent it with V, and its unit is meter per second, which is also the unit of velocity. Okay. Let's talk about this negative sign. Why this negative sign is? This negative sign indicate that the flow of water is in the direction of decreasing head. Means this is because this negative sign came just because of sign of convention, because we measure height here as a depth. We obviously water will flow in underground, so we measure from the ground. Okay, we measure the depth, and here that's why because of sign of convention, this is we use here negative sign, because we take height as a means negative entity, as a depth we are measuring from the ground and in a negative direction according to sign of convention. So that's why negative sign is used here. And there is some certain validity to apply this Darcy Law. Darcy Law is valid only for laminar flow, means it is not valid for turbulent flow. Darcy Law is only applied to laminar flow, and this formula, this specific formula which depends on one which used a one hydraulic constant conductivity K value, is for homogeneous anisotropic material. Okay, this formula is basically for homogeneous anisotropic material, and Darcy law is valid only for laminar flow. So this is all about Darcy law.